Hello, once again, welcome to Mathematics Boss #96. That's the YouTube channel. Make sure that you search there and like and subscribe also to our channel so that you can receive more of this content that are educative and are useful in your mathematics studies. So, for more inquiry, you can also reach out to me through that on WhatsApp. Today, I wanted us to go briefly through surds, and specifically, I just want us to look at addition and subtraction surds. Addition and subtraction of surds. Before we add and subtract surds, first of all, we must understand what are surds. And don't confuse being surd and surd. I want to pick a few of the numbers here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then I want to introduce the roots. Like that. Let us find the square root of this number, and we want to get exact answers. Exact value. Square root of 1 is 1. Square root of 2 does not have an exact square root, therefore I'm just going to write it as root 2. Root 3, we don't have square root of 3. Going to be root 3 because we need an exact answer. Root of 4 is 2. Root of 5 is exact root of 5 is root 5. Root of 6, we don't have an exact square root of 6, we're going to write root 6. Root of 7, we're going to remain root 7. Root of 8, we can leave it as root 8. Or we can write it as 2 root 2. I'll explain where this one is coming from. Root of 9 is 3. Now, out of all these numbers, you can see that there is a slight difference. There are values that they have exact root, and we have those ones that do not have exact square root. Now, these values like 2, root 3, root 2, root 5, root 7, 6, we consider them as surds. There are irrational numbers. They are irrational numbers. Well, the rest, like 4, root 9, the values like 9, they are numbers that have exact square root, so they are considered to be irrational numbers. So, after that, I also want to talk about simplification of surds. Simplification. Now that you know what surds are, root 2 is a surd, 3, root 5, those numbers. Like root of 49. Is this a surd number? That's a question. Do you have an exact square root of 49? The answer is yes. Square root of 49 is 7. Going to be 7. Simplification of surds. So I want you to understand why I had to write this one as 2 root 2, yet we have root 8. Take an example of value like 12. Then you are asked to simplify. 12 is a surd number. It's an irrational number. So I can simplify some of the irrational numbers. Not all, but some. Like 12, I can find the prime factors of 12. 12 can be written as 4 times 3. 12 can also be written as 6 times 2. 12 can also be written as 1 times 12, of course. Yeah. But my interest is this. I want 4 times 3 because 4 has an exact square root. So if I want to simplify with 12, I can do it this way. Then, root of 4 times 3 is the same as saying root 4 multiplied by root 3. What is root 4? Root 4 is 2. Root 4 is 2, so I'm going to say 2 times root 3. 2 times root 3, the answer is 2 root 3. So when we simplify root 12, we're going to end up with 2 root 3. Let us take another value, like 72. Can we simplify 72 root of 72? Yes. 72 can be written as 36 times 2. But 36 has got an exact square root, which can be written as root of 36 multiplied by root of 2. What is the square root of 36? You get that the result is 6 multiplied by root 2. 6 times root 2, the result is 6 root 2. Like that. Another one, do one more. Let us try 108. Square root of 108. We can simplify that. We can pick a number that has got an exact square root. Let us try that. 108 can be written as 1 times 108, can be written as 2 multiplied by 54, can also be written as 3 multiplied by 36. Yes, 3 multiplied by 36. So, I'm going to consider this because I don't have an exact square root of 54. So, I'm going to consider 3 multiplied by 36. Like that. Then this one will simplify to root of 3 multiplied by root of 36. But 36 has got an exact square root which is 6. So root 3 times 6 is 6 root 3. That's how you simplify surds. But today I want to talk about addition and subtraction of surds. The surds that maybe you may be required to simplify them before adding or subtracting. Let's go to the main agenda of the day. So let us start with the simplest one, like root of a plus root of a. Remember, for you to add or subtract surds, they must have the same value, like a and a. But if you have root a plus root b, then you cannot add the two because we have a and b different values inside the root. Now, root a plus root a, and you are wondering what is the answer? Can we say a squared? Just a question? Or the answer is a? Or what do you think? What I'm going to do, I will say let root a be y. So I'm going to put that on y plus, where there is root a, we are going to write y. What is y plus y? You get 2y. But what is y? That's the question. Y is root a. Therefore, the answer is going to be 2 root a. So root a plus root a is 2 root a. So if I have root a, again, plus root a, plus root a, how many times does it appear? 3 times. So we will say 3 root a. Let's get another value. Root 3 plus root 3. Someone will end up saying 3 root 3. No. How many root 3s do we have here? We have 2 of them. This, this. Therefore, they are 2 root 3s. Then you say 2 root 3. Let's consider another one, root 5 plus root of 5. Root 5 plus root 5, the result will be 2 root 5. Another one, let me consider 2 root 7 plus root 7. Now look here, we have 2 here, and here we only have 1 root 7. Therefore, 2 root 7, you can call it, you can say, let root of 7 be x. So when there is root 7 substitute with x, we have 2 into x plus x. 2 times x is 2x, plus x is 3x. But what is x? X is root 7. Therefore, the result is going to be equal to 3 root of 7. Therefore, 2 root 7 plus root 7, the answer is 3 root 7. We can advance 5 root 3 plus 8 root 3. Take the elements outside the root. 5 plus 8. 5 plus 8 root 3. What is 5 plus 8? The result is 13 root of 3. And that becomes the final result of that particular question. At times you can also meet a more advanced question that needs first of all to simplify. Like let us take an example of, let us consider root of 72. 72. maybe 32. Like that. So what you do, first of all, you simplify. When you simplify 72, from the previous question, we had done it and we got the root of 72 is the same as 6 root 2. So 72 can be written as 6 root of 2 plus 32. This is the same as 16 times 2. Square root of 16 is 4. Therefore, this one can be written as 4 root 2. Now you see, we have the same root. Therefore, I'll just take the elements after the root. 6 plus 4, that is 6 plus 4 is 10 root of 2. And you have that right. Even if you want to perform subtraction, you do the same thing. In case this was here. 5 root 7 minus 2 root 7. You take the elements as long as whatever is inside the root is the same. 5 minus 2 root of 7. 5 minus 2 get 3 root of 7. Maybe you can contradict you a bit. What about if you read a question like root of 256 plus root of 108? How do you go about it? Do you have an exact square root of 256? The answer is yes. The answer is 16 plus 108. You have seen that 108 can be written as, if you review from the previous work that we have just done, you notice that it's going to be 6 root of 3. Now we have 16 plus 6 root 3. Can you add the 2? The answer is no, because this is just a rational number, 16 here. It doesn't have a root. And here we have a root. So there is no way we can add. This is just like being told x plus 3, 1. When you add x plus 3, 1, there is that remain the same. Therefore, if you sum up the two, this is the answer. Even if you decide to introduce a different sign, you still have it as 16 minus 6 root 3. And we need to take that. And that's how we can easily add or subtract signs. Tune in for our next lesson where we talk about multiplication and how to rationalize the denominator and some part of applications on signs. Thank you very much for tuning in. This was your math course, mathematics course, aka SOP. So thank you very much. Make sure to tune in, subscribe, like, and share. Bye bye. Have a blessed day ahead.